Hello everyone, and we're back with example number 3. Let's take a look at what this question says. The question says that we have a black ball of mass 50 gram and this ball is placed on a snooker table. And we are saying that when this ball is hit with a white ball, then this black ball enters the pocket behind it and it does so in half a second by rebounding with an angle of 60 degrees from the front edge by traveling a distance of 100 centimeter and by making a complementary angle with its resultant vector. If the black ball strikes the front edge with velocity of 5 meter per second and then moves with a constant acceleration, find the impulse acting on the black ball. These are our options and the right answer comes out to be option number C, that is 0.18 Newton second. Now, of course, this sum is a classic example of how the examiners try to intimidate the students by making you think that the sum is a difficult one. Actually, the sum is pretty simple. It is only the geometry of the problem that we need to understand, and to do that, we must pay careful attention to the words in the sum. Let's quickly solve this very simple problem. What we have first is a snooker table, and on the snooker table is our black ball over here, which has a mass of 50 gram. Let's first try to visualize the motion of this white ball hitting the black ball and see if you agree with the animation in the picture. When this white ball hits the black ball, the first thing that is told to us is that the black ball enters the pocket behind it. Now look at this black ball. Which are the pockets behind the black ball? Behind the black ball means this pocket, or it could be this pocket, or it could be the pocket on the left. But then it also says that it is rebounding with an angle of 60 degrees. So if it is rebounding, it means that it must be hitting somewhere on the top and coming back and going into this pocket. And therefore, we have understood that this white ball, when it hits the black ball will hit the front edge, as it is said. It rebounds with an angle from the front edge. So it's going to hit this front edge, rebound and go into that pocket. And the angle it will make with this front edge is going to be 60 because it is rebounding with an angle of 60 degrees. They are also saying that it does this rebounding after traveling a distance of 100 centimeters and by making a complementary angle with its resultant vector. So let's quickly see the motion. As predicted, if I hit this white ball to the black ball, see it rebound from the front edge and go and fall into the pocket behind it. So now I'm going to make a triangle out of this motion, and these are my vectors. One vector is here and one vector is here. And now I will make the resultant vector. So you can see this is one vector and this is the other vector, and therefore my resultant vector is this one. And it is saying that it makes a complementary angle with the resultant vector. That means this angle is 30. Complementary angle means that if this is 60, then to find the complementary angle, you will subtract this from 90. So complementary of 60 is 30. Complementary angles are those angles whose sum adds up to 90. And therefore, they are saying that this ball is making a complementary angle with the resultant, and this vector has a resultant of OQ. So OQ is the resultant and this angle is 30 as given in the sum. So this is the brief diagram of the sum. Now let's write down as much as we can from the information given. We know that the mass of the ball is 50 gram as told to us in the sum. We also know that this displacement OP is 100 centimeter. So let's call this displacement OP as S1. Now I'm going to use the information that V1 is 5 meter per second. First of all, take a look at what is V1. Is V1 the velocity here? No. V1 is the velocity at this point P. So what is the velocity at point O? The velocity at point O of the black ball is 0 because initially the black ball was at rest. The velocity of the black ball at point P is 5 meter per second, and you can see that it is told to us black ball is striking the front edge with velocity 5 meter per second. So velocity here is 5 meter per second, and that's what I'm calling as V1. So remember, I am analyzing the motion along the first part, that is along OP. And in the path of OP, I say that V1 square, where V1 is the velocity at the final point, is equal to U square, where U is the initial velocity at O, plus 2as1, where s1 is the displacement between OP. So I have used the kinematical equation, the third kinematical equation, for this portion of the motion. So now I will put the values and I will see that because the object, that is the black ball, was at rest initially, it means velocity was 0 initially, and therefore u was 0, and therefore this will give me that a is v1 square upon 2s1 because u is 0. And this I will save because I am going to need it later. I will also remember that the displacement OP is nothing but 100 centimeters because that has been told to me that it is rebounding from the front edge after traveling a distance of 100 centimeters. So S1 is 100 centimeters or 1 meter. Now I will take a look at the triangle. Now in this triangle, I will look at this angle, that is 60 degrees. And if I try to write down what is the cos of this angle, remember cos is adjacent upon hypotenuse. So what is the adjacent side? The adjacent side to this angle is 100 centimeters. And what is the hypotenuse? The hypotenuse is PQ. So now I will say that cos 60 is equal to OP upon PQ, where OP is nothing but 100 centimeter or 1 meter and PQ is the hypotenuse, and cos 60 I know is half, and this gives me the value for PQ, that is 2 meters. So I have found what is this distance PQ, that I will call as S2, that is 2 meters. So I have S1 as 1 meter and S2 as 2 meters. Now using this information, I will finally get what I want. I have found the velocity at this point. I know that initially the velocity was 0. I have found the velocity at this point, that is v1 is 5 meter per second, and I know that from here to the end the object is traveling with a constant acceleration that is given to me, and I will use this information in the analysis of the motion in the second part. So now I am analyzing this motion between P to Q. So for this motion, again I write the kinematical equation v2 square is equal to v1 square plus 2as2. Now what does this mean? v2 is the final velocity, the velocity with which it hits the pocket. v1 is the velocity at this point. s2 is this distance which I already know is 2 meters. So what else do I need? I need to find what is a. Now I will write down the values in this case. In this case, I know that v2 square is equal to v1 square plus 2, and instead of this a, which is the acceleration between P and Q, I will write down this acceleration. Now why is it that I can write down this acceleration? This acceleration was for this portion. How come I am writing the acceleration of this portion in PQ's motion? It's because it is told in the sum that the acceleration is constant from this point onwards, and therefore whatever is the acceleration in this portion will be the same in the next portion, and therefore I can take the A's value from here, and therefore from this I can find the value of V2. Now if I rearrange this formula, I will get the value of V2 as V1 square 1 plus S2 upon S1, the whole thing under root. So now I will find the value of V2. What is V1? V1 we know is 5 meter per second. So V1 square is 25. 1 plus S2 upon S1. S2 is 2 meter and S1 is 1 meter. And this gives me the value of V2, that is 8.66 meter per second. So finally I have found the velocity at point P and the velocity at point Q. And what is it that I want from the sum? I want to find the impulse acting on the ball. So let's find the impulse. Impulse by formula is nothing but the change in momentum, and therefore I will get m v2 minus v1. And what is v2? V2 is the final velocity which we found. M we know is 50 grams, but that's not an SI unit, so I convert it to kgs. 15 to 10 raised to minus 3. V2 is the final velocity 8.66 and V1 is 5 meter per second given to us. This gives me the impulse or the change in momentum, that is 0.18 Newton second. So this is the final solution that I am talking about. We needed to find the impulse acting on the ball and we got the answer 0.18 Newton second. It was not at all difficult. It was just lengthy because of the geometry of the figure. So sometimes you will have a lot of details, but the question will not be difficult. So don't get intimidated and keep on going. So thank you for watching this video. If you like our channel and want us to make more videos, please subscribe. The link is given below. You can also buy your very own target book by clicking on the link given to you. Till then, keep watching and stay tuned.